When you're ready to go live with your trading system, it's a good idea to deploy them to a cloud server. That way you don't have to worry about internet outages, power outages, and a whole host of other issues which are much more likely to occur on a home server than a cloud server. As if you miss an entry or an exit on a trade, that could be a very, very expensive ordeal for you. And since the vast majority of internet servers run on Linux, as it's cheaper and, in my experience, much more reliable than something like Windows servers, I thought I'd make this video to walk through the basics of how we interact with a cloud server, completely platform independent. This will work for AWS, Azure, Google Cloud, DigitalOcean, Linode, and it doesn't matter which platform you're on. I'll go through and specify where there are any differences between a Mac, a Linux, or a Windows system. So the first thing that we need to go ahead and get started here is a hosting provider. So like I mentioned just then, you can use AWS, Azure, basically just any hosting provider that can host virtual machines. That's the keyword you want to type into Google. Feel free to just look for the cheapest one. I use DigitalOcean as they have a very simple pricing plan. You just pay basically a fixed monthly amount. Whereas with services like AWS, there are lots of variable costs depending on bandwidth usage, and I just prefer the fixed costs. So make an account on whichever virtual server provider that you're after. I'll click over into my DigitalOcean account here. And in our case, the server's called a droplet here, but it'll be very, very similar no matter which provider you're using. For AWS, it'll be EC2. They'll all have basically the same information. You'll get a choice of operating system here. I would personally recommend going with Ubuntu and Debian. That's what I'll be walking through in this video. Either of these two should be sufficient. I'm going to go with Ubuntu, as that's the one that I'm personally the most familiar with. You'll then have to pick a pricing plan of some kind. Now, depending on what you're hosting on the server, your hosting costs can vary quite a lot. So a very simple trading bot you can run on the cheapest servers that they provide here. So 1 gig of RAM and 1 CPU will be more than enough. If you need to host a large database for a stock screener or something similar, then you'll probably want to step this up to maybe 4 gigs of RAM and 2 CPUs. It all depends on the kinds of services that you're trying to run. But for a simple Python script, I think we're good here at the $6 a month plan, so I'm going to pick that one. Next, you'll want to pick a data center. Ideally, you'll want to pick one that's closest to your broker to minimize any latency issues that you might get. I'm not actually going to do any training in this video, so I'm just going to pick one that's relatively close to me, so I'll pick the London one. You'll then get a choice of authentication methods. So you can either pick a password-based authentication or an SSH key authentication. So the difference is basically the password, anyone can log into your server provided they have the password. And what this lets people do is random people on the internet can try to guess the password on your server. And so if you don't have a very secure password, it can be fairly easy for someone to get access to your server, which is something that you really, really don't want, especially if you've got your credentials on there for your trading platform. So a password is generally the less secure of the two. SSH keys use cryptography in order to gain access to your server. It requires a little bit more setup, but ultimately it's a lot more secure, and so it's worth it when you've got a machine with sensitive information on it like the one we have here. And if you're not familiar with SSH keys, basically there's just a file that we have to keep secure on our computer, and whenever we connect to the server, all we have to do is prove that we have that file, and because we have that file, we're now allowed into the server. Ultimately, this decision's up to you. I'm going to select password authentication here, and then we can add SSH key authentication later on to make things a bit more secure. So as I mentioned earlier, we need to be mindful here and we need to have a relatively secure password. So I'm just going to use my trusty password generator here. I'll generate one of length 20 and we'll use one of these. So just copy and paste that in. Make sure that you keep that safe, as if you don't have that, you're not going to be able to connect to your server. Apparently it can't end in a number, so I'll add another letter on the end there. And we're good to go. Then there's a bunch of additional options here, like backups, monitoring. We can add that, sure, it's free. IPv6, don't worry about it. And then we'll have to choose a name for the host here. So I'm just going to make mine called Linux Video. That'll do for now. And we're ready to go and create our first server here. It might take a few seconds for the server to properly spin up here. But again, every platform should have some sort of metric screen where you can look at the graphs here. You can see that it's online, and if you wait a minute, you'll be able to see the CPU usage, the disk usage, and how much internet bandwidth it's using. This is your IP address up here, so there should be an IPv4 somewhere, and that's how we're gonna connect to the server. The method of connecting to the server differs depending on whether you're on Windows or whether you're on Mac or Linux. So I'm going to jump over to my Windows computer right now and show you how you would go about connecting to the server. So here we are, I'm on a Windows machine, and the first thing that you'll need to get connected is a SSH client. So the most common one that people use on Windows is PuTTY. So you can just Google PuTTY and go to putty.org, and there's a download there where you can install it. I may already have it installed. No, I don't. So I'll install it here. This might look a bit scarier, but basically just pick the correct installer, depending on whether you've got a Intel or AMD CPU or whether it's 32 or 64-bit. Worst case scenario, just try all of them until one of them works. But I believe this one should work for me. So it's very much a standard Windows installer. Hopefully nothing too strenuous in there. And then you can go and open up PuTTY. So all you have to do here is type your username at the IP address. So the username by default on DigitalOcean is just root. It might be different depending on your platforms, like Azure uses Azure user, and I think AWS uses Ubuntu as their root user. So just make sure that you've got the right username there. That will depend on your platform. Just Google that. And then do an @ symbol followed by your IPv4 address. So for me, that's going to be 46.101.13.231. You can leave pretty much everything else as default. You can save this if you want. So I'm going to save this to my server. And that will save a profile here with these settings so that whenever I log back into PuTTY, all I have to do is double click this, and that will try and connect. This pop-up window is basically saying that we've never connected to this server before, so just click OK. And it's asking us for a password, so that's a good signal. It means that we're actually getting through to something here. So I'm just going to type in that really long password that I set earlier. As you can see there, I was having some fun mistyping that very complicated password that I entered. But once you're into the system, you'll see a screen a bit like this. Now we do have to type in our password every single time that we open a PuTTY window here. That's something that's really great about SSH keys. You don't have to do that. If you want to customize the experience that you've got here, you can do that from within PuTTY. So I'll close out of this window. If we go back to PuTTY here, I can load up my profile that I made before. And I think it's in appearance, font here. You can change things like the font size. So I like to have mine quite large, especially for tutorials. So you can do that. You can change the font there. Go back, save this back down to this session here. Open it up, and when I type my password back in here, you can see that the text is a much more readable size here, especially if you're going to be staring at this for a while. So that's all we need to get into the system here. I'll switch over now back to my Linux computer, where I'll show you the instructions for Linux and Mac. So to connect to your server from a Linux or Mac system, it's much simpler than it is on Windows. All you need to do is just grab the IP address here, open up a terminal, type the word SSH, then username, so it's going to be root, at least for DigitalOcean. That may vary depending on your server provider, or you may be able to set that yourself. You'll have to look into that if you're using a different provider. And then just paste your IP address here, so paste that in. It will then prompt you for your password, so I have that safely stored away here. If I paste that in, we're now into our server, and we can continue the tutorial. So the first thing that you might want to do now that you're in your new system is have a little look around. And we do that with the ls command, so you may have seen that before. We are currently in our home directory here, so that is signified by the tilde sign here. So tilde sign means home. If I do ls tilde, it tells me what's in my home directory, which we happen to be in. I can make a folder with make dir, so make dir test, that makes a test folder here. I do ls, and that shows us that that folder has been created. And then I can just cd into that test folder with cd test. So cd stands for change directory, and that's how we move about between folders in Linux. Now, if you want to get out of this test folder, few ways to do that. You can do cd tilde here, and that'll take you straight back to home. So if you ever get lost, just do a cd tilde, and you'll be back to where you started. Alternatively, if you were in this folder, and you just say we had another folder in here, so make the test2, cd test2, and you wanted to just go up one level, you want to go back to the test folder, you can do cd ... and that'll take you up one level. That's a helpful shortcut that you might want. And you can keep going up as far as you want, so you can go right up here, and you can mess around with any of these scary folders here that contain system files, although I wouldn't necessarily recommend that you do. So we'll return to the home folder for now, where you'll be spending most of your time. Python should be installed by default on most Linux systems. On Ubuntu, it's usually Python 3 that you have to call, like that. So you can see Python 3.10 is installed on here. This is just a regular Python interactive terminal. You can just exit like that. But usually pip isn't installed. So you can see there, I tried to use pip. Again, it's pip 3 for Python 3. And quite often what happens on Linux when you try and use a command that is not available, it will give you the installation instructions here. So apt is Advanced Package Tool, I believe. And so this is your multi-tool for installing programs, basically. Generally, whenever you see apt, that means you're going to be installing or uninstalling or upgrading something. So apt install Python 3 pip. That sounds very reasonable here. Now, we're the root user here, so we can just go ahead and do that. And then it'll ask us, this is going to take up some extra space on your hard drive. Are you okay with that? Yes, I am. It might ask you some scary stuff here, but you can just basically skip down to the bottom here, not worry about it too much. Just click enter, and there you go. For the most part, installing programs on Linux is really quite that easy. So I've got pip installed. I can now just go ahead and install some Python packages if I wanted to. So pip3 install pandas, for example. We can see here it's giving us a warning at the bottom there that running pip as root can sometimes break things. So generally, you want to use a virtual environment, which is basically just a special folder containing your install of all the different packages. And that way they're all contained in one place. They're not installed in various places around your system. And if something breaks, you can easily just make a new environment. So if we try calling virtual env here, I get the feeling it's not going to be installed. But again, it gives us this lovely install command here that we can run. Note that if you aren't the root user here, and if this command fails for some reason, you might have to do sudo apt install. Sudo is going to give you super user privileges here so that you can make changes to the file system, like installing a new program. We don't need that because we're root, so just apt install Python 3 virtual env will work for us. So if I do an ls here, we can make a new virtual environment. So virtual env, venv. It'll take a second, and you can see it's created this new folder, which is going to contain all of our new installed packages. To activate that virtual environment, all you have to do is do source venv/bin/activate. You can change venv to be anything you want here, but just conventionally it's called venv. You can name it anything you like. And then you'll see that it's properly activated because you have the name here on the left hand side. And now when I do pip install pandas, that should work just fine. You'll notice that I just used pip install pandas there rather than pip3 install pandas. That's because we're in a virtual env here, and so pip will usually redirect you pip3, but if you want to make sure, you can just do pip3 install pandas or whatever software you happen to be using. So that's nice. We've covered how we can move around on the system with ls and cd and make dir. And we've covered how to install things, so we've installed virtual env and we've installed pip, which we can then use to install all of the other Python packages that we could ever want. The next thing that we'll want to do here is to actually transfer our code over to the server here so that we can actually start working with it and running our trading system live. So here I am again on the Windows machine. I'll do an ls in this terminal here, and you can see that updated, so all the files are still the same from the edits I made on my Linux machine over there. And the tool that we're going to use here to do the transferring of files is called WinSCP. So you just go to winscp.net, and you can go ahead and download that free of charge. You can just click through all the options there. The defaults usually work with these things. Looks like there's a nice button there to import our sessions into WinSCP from PuTTY, so that's quite helpful. We don't have to retype our IP address in there. So you can see it's pulling this my server profile. So it looks like that's finished installing there. We can launch WinSCP here. It'll ask us to log in to a server. So I can just click this one here and I can click login. It'll ask me for my password. So I'm just going to copy paste that in. And you can see we've got the file system on the server on the right and the file system on our system on the left here. So this is looking at my documents here. So I'll just make a random file in my documents that we can move along. So let's just make a new text file and we'll call it test. So we can see that is in my documents here. To transfer it over, all I have to do is drag it over like that. It'll give us a confirmation window here, but you can basically just do that. Same thing works for transferring folders or any other kind of files that you might have on your home computer. It's super simple to use with the graphical interface here. On Linux and Mac, the procedure is again a bit simpler than it is on a Windows system. So I'll go to the folder I'm using for this video. And so let's say I want to transfer this script.py over to the server. So script.py looks something like this. It just gets the price of Bitcoin. How do I do that? Well, I'm going to open a terminal inside this folder. We can check that with an ls here. And then I'm going to do a sftp command. So Secure File Transfer Protocol, I believe that stands for. And then we enter the same username and IP address as we did before for the server. So I'll just go grab the IP of the server here and paste that in. And then we'll need the password. And what you can do here from the sftp command is, well, you can use ls to have a look around. You can cd into folders, I believe, if you want to. So cd test, cd double dot should work. There we go. And all I have to do if I want to place a file onto the server is use put. So put, and then the name of the file, so scripts.py. And that's going to place the script in whatever folder I'm currently in. So it uploaded the file there. If I do an ls, we can see that that file has been transferred over. If you want to move an entire folder over, all you have to do is do put -r and then the name of the folder. -r means recursive, so it will continuously search out for new files within that folder and upload them to the server, including the folder itself. If you ever wanted to retrieve something from the server, you could use the get command. So get test.txt, we can get that test file that we had earlier. And that's pretty much all there is as far as transferring files between a local machine and a Linux server, if you're on a Linux or Mac machine yourself. Now, there is a third option here. If you store your code on GitHub, Then a much easier way to get your files over to your server is you can just do a git clone. So for example, I'm going to look at this GitHub repo here for backtesting.py, which I use very often on the channel. And what you can do is you can go to this code section here, go to HTTPS and click copy to copy this link. And if we go back to our server here, you can do git clone and then the URL there. And what that will do is that will transfer all of the code from that GitHub repo onto your machine here. Using Git is a super nice method of managing all your different files, and you'll probably want to move to it eventually as your project grows, and just manually transferring files backwards and forwards becomes a little bit difficult to manage. But this is not a Git tutorial, so I'm going to leave that for now. The main thing is that we have cloned our code down to the server, ready to be run. If you're using a private repo there, you'll have to enter a token, which you can generate from your account settings. I'll leave a link to instructions for that in the description below. So now that we have our little Python script here in our root directory, how do we go about running it? Well, since it's a Python script here, all you have to do is type python3 and then the name of the file. So script.py. I'm using tab there for autocomplete, and it'll run this script. And well, it won't run the script because we need to install requests, but after I install requests, it should work. It prints out the price of Bitcoin there, and it saves it to a file here called prices.txt. So this brings us on nicely to our next topic here, which is reading text files in a Linux system. I personally like to use Vim, which is a very simple text editor that's been around a really, really long time. Obviously, we're in a terminal here, so programs like Microsoft Word or Visual Studio Code don't really work quite the same. So if you just type Vim and then the name of the file that you want to edit, so I'm going to go look at the script that we had earlier. So vim script.py, that will open up this window. And to move your cursor around, you can either use the arrow keys or you can use H, J, K, and L. That's personal preference. And as a super quick primer on Vim, basically, if you just want to make some minor adjustments to a file without any hassle, all you have to do is just move your cursor to the place that you want. So I'll go to this empty space here, press I to go into insert mode. Then you can type whatever you want to type. So I'm going to type print price again. Let's just do that. Then put a few empty spaces in. Click escape to get out of insert mode. Now I can move my cursor around again. If I wanted to delete this, say I wanted to go into read mode, go into insert mode with I, then type as normal. So delete with backspace, press R, and then escape gets me out of insert mode there. That was a super simple 5-second intro to Vim there. I'm sure you can find better tutorials out there on the internet. But it will be important for you to acquire some basic terminal text editing skills. You can also use things like Nano, which is another text editor. I don't particularly like it. And there are a myriad of other tools which you can migrate to later on. But I'd recommend just starting with Vim. That's what I find the simplest and most intuitive. So we've got our file transferred across. We've ran it once, but that's not particularly interesting. If you've got some kind of automated trading system, you want it to be running all the time, or at least maybe if it's some kind of data scraping system or stock scanner, you'd like it to at least check things maybe once an hour or every 10 minutes or something. How do we go about implementing that in a Linux server? Well, a really simple way to get a script to run all the time is to go into the script here. And what we could do is we could just do something like this. We could indent all of this code. We could do while true here. So just repeat this in a while loop and do time.sleep, say 3 here. So we'll sleep for 3 seconds. We'll do the whole thing and then we'll sleep for another 3 seconds. So this would be a very, very simple way of doing things, and if you know Python, then you can probably implement something like this in your code if you're a bit scared of doing things directly in Linux. And so when we run our script here, what will happen is every 3 seconds, it's going to print out the price of Bitcoin here, and it's going to do that forever. Now, the problem with this approach is that if we ever exit this terminal window, this process will also stop. Now, obviously, that's not ideal because we haven't really gained anything if we have to keep our computer on all the time compared to just running the program on our home computer. So how do we fix that? There are a few ways of doing it. A very simple one is to use a program called Tmux. So let's see if it's installed by default. It is. So if you I'll do that again. If you type the word Tmux here, just Tmux, that will open up a window that looks maybe a little bit different from what you're used to, but all your normal commands work just fine. And if we go back into our venv here, you can see we've exited out of it. What I can do is I can run the script here, and then I can close this window if I want. So I'll do it just to show. So I'm going to close this terminal window here, and then we'll reopen it. So I'll go open a new terminal window. I'll grab the IP of my server here. SSH root at this. Copy and paste the password in. So we're back here. I can type in Tmux attach here, and that will pull me right back into this session. Now, there are a real large amount of things you can do with Tmux. I don't have time to cover that today. It would be like a 2-hour tutorial on its own. But I'll give you the 10-second rundown here. So you can open a new tab by typing Control-B, then C. So Control-B is one press, and then C afterwards on its own. That opens a new tab here. You can switch between them by doing Control-B and then the number. So Control-B 0, or Control-B then 1, Control-B then C as a new window, etc., etc. You can escape the Tmux session by doing Tmux detach. And then you can get back into the Tmux session by using Tmux attach. And you can have a bunch of Tmux sessions open at once, but again, that gets a bit complicated. So essentially, our setup here is we have a Tmux window, and within that Tmux window, we have our Python script running on an infinite loop. Now, it's not the most stable of systems because the Python program could run an exception, and in that case, the program would stop, and we wouldn't know it would have stopped, and there's a whole host of other issues there, which I'll show you how to deal with in a minute. So if we escape out of this Tmux session, one way that we can tell that the program is running here is by running a program called Htop. So if I run Htop here, what this does is it gives you like a system manager kind of view, like a task manager view of what's happening. So by default, it's sorted by CPU here. So what is using most of our CPU? You can sort it by memory usage. You can sort it by the ID of the process. You can see how much memory is being used on the system, how much CPU, etc., etc. And you can see that our Python 3 script.py is being run. And you can filter this by using F4 here, and you can just type in Python, and that'll pull up all this stuff here. And so now we're only looking at Python processes. Again, you can dive super deep into Htop and figure out all of its little niches. But the basic usage is you open it up and you can see what's consuming most of your CPU, which is probably going to be your trading bot. And it'll give you a good idea about whether you need to upgrade to a larger virtual server or not, or whether something horrible has happened and your processor's eating all the RAM on your box. If you do want to stop a process, you can do that from Htop here. So I'll do another search here using F4. So I've searched for our script here. And if I want to stop that script at any moment, I can use the F9 button. So you'll see at the bottom of the screen there, it gives the keys. So I can use F9. This will give you a whole range of different signals that you can use. Again, feel free to read the manual on this. But kill -9 will make sure that the process actually dies. So if I run that, you can see that process is no more. And if we do a Tmux attach here, and I go back to the window here, you can see it got killed by the system. So that can be nice if a process just goes rogue on you. it can be helpful to end them like that. So there are a few more things I want to point you towards before the video ends here. And the next one of those is using cron jobs. So what this allows you to do is to run a script on a periodic basis. Extremely, extremely useful. Maybe you've got some script that checks the status of your system and you want it to check every minute. Well, how do you do that? One nice way of doing that is with a cron job. So the way we would define a cron job here for this particular script is to first open the crontab file. Now, every user has a crontab at crontab-e. So if you run that, that will open up the crontab for your particular user. So we don't have one here, so you can select your text editor here. I'm going to select Vim here, so that's number 2 because I don't want to use Nano. There's a bunch of comments here showing you how to use the file, but essentially what you do is you come down to the bottom here and you add the frequency with which you want to run the command and the command which you want to run. So I'll detach from this Tmux window here so it's a bit more clear. A useful website for dealing with crontabs is crontab.guru. So if you go to crontab.guru here, what this will do is this will translate crontab's format for date time into a more human readable format. So for example, if you type this sequence of letters and symbols here, crontab will interpret that as run this command at 4:05 a.m. Whereas if I just do star, 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 that means every single minute. So the first item here stands for minute, then the second one's for hour, the third one is for day of the month, so the first, the second, the third, etc. The fourth is for the month here, and the fifth is for the day of the week, so Saturday, Sunday, Monday. So if I want to run a script once an hour, I could do this. So this will run every hour out in the 0th minute, or if I want to run it every hour at 30 minutes past the hour, you can do something like this. You can mess around with these different values here. You can do things like I want to run it at 10 minutes past the hour and quarter to the hour, so 45 here. There's a bit of a learning curve, but ultimately you get the hang of it. So let's return back to our script over here. And so I'm going to run this script every minute, mainly for demonstration purposes so that we can actually see it's working. So that's just going to be 5 asterisks here. And then the command that you put in here, you have to be pretty careful with it. Crontab can be quite finicky. Essentially, the crontab doesn't have the same sort of defaults that you might have as a user. So whereas I can do something like python3 scripts.py, crontab doesn't necessarily understand that without further configuration. And so we have to be very explicit in how we put things. Now, the way to do this simply with a Python virtual environment is if you look inside the venv here, and you go inside bin, you can see there's all these different binaries in here, but basically there's one for Python, Python 3, and Python 3.10. And so what we're going to do is we're going to tell crontab, I want you to use this specific Python binary here when you run our script. Because after all, we want crontab to run the script inside our new fancy virtual environment here. So I'm going to go back to script. I'm just going to remove the while loop because we don't need it. We're going to run it on a timer using crontab now. So I can get out of here. And so all I have to do is point crontab to this specific Python executable here. So we'll go back into the virtual environment folder, into bin. And if you do pwd, that will print out the full directory of where you currently are in the Linux system. So it's /root/venv/bin. So I'll copy that and I'll paste it over inside our crontab here. So we're going to do /root/venv/bin/python3. So that's the command that we're running. We're telling crontab we want to use this particular version of Python. And then we also need to tell it to use the particular script. So that's going to be /root/script.py. Now, that crontab here should be installed if we get out of here. I forgot to mention earlier when talking about Vim, if you want to write to a file, it is : then W, press enter. If you want to exit and write, it's : WQ, enter. So you can see it's installing the new crontab here. Now, personally, I never trust Crontab without first confirming that it's actually working. So we can probably do something like tail f on prices.txt here. What should happen, ideally, is a new value is going to get appended to prices.txt once every minute here. So when I was messing about with this file before, I changed that to a W, so I changed that back to A for append rather than write. But you can see the file got wrote to there, so if I do this command again, that will follow the output of the file, so we get to see any new lines that get added to it. So there we go, you can see that worked, although it didn't append it in quite the way I imagined, it just appended the result directly on there. But if I were to go ahead and leave this for a couple of days, I'd come back and I'd have a whole bunch of nonsense written about Bitcoin prices here in this file. So the cron tab is at least working, and obviously to remove the cron tab, all you have to do is do crontab/e again, go down here, and you can comment out or just delete the line, and that will now not work. So Crontab is definitely one way of running programs on a loop or at specific time intervals to make sure that everything's working properly, basically. If you want to get a bit more advanced, a bit more in the weeds with things, you can use systemd to set yourself up a script that will always stay running, and if it dies, it will automatically restart itself. And equally, if you ever reboot the server, it will automatically start up and that kind of thing. So I'll show you a basic systemd config here, and then you can build on that yourself. There are many, many good tutorials out there on how systemd works. So in order to create a systemd config file here, you'll have to use vim again. And so you'll go to vim/etc/systemd/system. So in here, you're going to put your config file. So if you do another / and then the name of the file you want to call it. So I'm going to call mine system. Oh, no, I'm not going to call it system. That might be a conflict. I'll call it trading.service. So whatever you want to call it, .service. That'll open up a blank new Vim file here. You may have to do sudo vim if you're not the root user, as this is a protected file path. So once we're in here, we can just copy a template systemd file here. I've just got one that I found on the internet here. You can copy this out if you want to. Change the description here to, our super important trading script. This here will make it sleep before it starts up. That just gives the system some time to wake up if you've rebooted it recently. Or if it dies, I think it will also give it some time before it restarts it again. The main line that you want to care about here is just this one. And that's going to be exactly the same as it was previously with our cron tab. So I don't remember it anymore, but it's going to be something like /root/venv/bin/python3 and then /root/script.py. So that there is going to actually execute this script. So we can see what happens if we start this up. We can see if it fails. The way to do that is to do systemctl daemon reload. And that's going to reload all those files. So it's going to discover your config. And then you can do systemctl enable trading.service. Once you've done that, you can now do systemctl status trading.service, and that'll let us know what's going on. So we can see there, it appears to have died, so that's not great, but we'll see why in a second. If I do systemctl start trading.service, see if I can get it to start, it'll do the sleep for 10 seconds there and try running it. If we check our status here, you can see it sometimes gets restarted here. So you can see it's kind of alternating between sleeping and being awake. I'm just running the status command over and over again here. Now, this is kind of okay, but not really the behavior that we were after. What systemd is kind of good for is keeping a program running that's supposed to be running all of the time. So with Crontab, there's this script that needs to be run at regular intervals. And so we specify a time at which that's going to happen, and it goes ahead and does it for us. With systemd, it's like it's watching the process for us, and if it dies, it goes ahead and restarts it for us. The problem with our script here is that it just kind of runs once and then dies. So we need to re-implement that while loop that I had before. So we do like a while true here. And now systemd should like it and actually run properly. So if we go back to systemctl status, we can see it's running, still running, still running, still running. So basically, everything's working as it should now. So systemd is quite useful if you've got some trading bot or some scanner that needs to be running 100% of the time, and it should automatically restart if it dies. Systemd can be one way of managing that, as it's nice and pre-built into the operating system here. So just to show you what happens with systemd, if I go back to Htop, which you remember from earlier, I go hunt down our Python process here. So where is it? This one. Let's say I kill this process. So I'm going to do a sig kill -9. If I go back here, you can see it's now stopped because it's been killed. And then after a break of 10 seconds, which was the sleep window that we set in the config, it should now start up and running again. So that kind of, I don't know, simulates rebooting the system or just raising some unhandled exception, but you want to restart again as quickly as possible. Systemd has got you covered in that regard. So that's a little bit of a crash course on how to keep your processes running, how to leverage the operating system to make sure they're running all the time or periodically as you require. One thing I'd like to show you now is just the very basics of Docker, because that can be another really powerful way to deploy things on a Linux machine, especially things like databases or any kind of pre-built project that someone else has made. You can deploy that and have a pristine copy, all configured and ready to go on your own server, very, very, very easily using Docker. So if we go to Docker here, just go to their website. It's not the most informative thing in the world, so we'll go to the Docker install guide here. And what I'm going to do is I'm going to run a timescale DB instance here. So timescale DB is very useful for saving down time series data. So let's say you're streaming tick data from a exchange. I like to use timescale DB to save everything down, but setting up and configuring databases is quite a hassle, especially if you want to have multiple databases on the same system. If you try and uninstall one, you'll have configurations left over from before. It can be a real mess. And so to avoid all that trouble, we can just run a Docker instance. There's a whole host of things you can do with Docker, but for our purposes, it's an easy way to install difficult to install programs. That's how we're going to think about it. So if you just go Docker install, you can find over here, go down to server, pick the operating system that you picked. So mine's Ubuntu. And then you basically just want to go down and copy and paste every single one of these commands here. I'll speed through this because it does take a little while, so I'll just copy and paste all of these commands. So Docker has been installed here, and now all I have to do to run a timescale DB instance is, well, I just go to the instructions here. I need to pull a specific image, so that's like downloading the installer, basically. That can take a few seconds. And then after that, we just literally run the instance here. Then all we have to do here after that's installed is we just copy the next command here to run the container. Press go. And if I do docker ps here, you may have to do a sudo docker ps depending on your user. You can see I've got a timescale database up and running here. I can get into that with another command I can find on here. So this docker exec command. There we go. I just had to stop it and start it again for some reason. But there we are. We're inside our Postgres container here. And we have a fully functioning database. Equally, if I decided that I didn't want a timescale database and I wanted Mongo instead, all I could do is I could just do docker stop timescale db. We'll go to Docker Hub, look for MongoDB. Looks like it's Docker pull Mongo, so Docker pull Mongo. And there we go. If I do docker run mongo, we're up with a fully functional MongoDB instance here, which I could use to store trade data or sentiment data or any other kind of data that I like. And it'd be super simple to switch between the two, just using Docker to orchestrate everything. Again, this isn't a Docker tutorial. I'm just trying to show you the power of Docker, and then you'll be more motivated to actually study how Docker works, why it works, and how you can leverage it to run your trading systems more efficiently. The last thing that I'm going to cover here in this video is how to increase the security of your server a little bit more by using a combination of IP whitelisting and SSH keys. So IP whitelisting is relatively straightforward. You'll usually have some kind of networking tab from within your cloud provider of choice, and there should be some method of whitelisting IPs basically. So you can see we've got a firewall here. So I can create a firewall and I'll call it test. And what I can do is I can say that only my IP address is allowed to connect here on port 22. So if I go to what's my IP here, this is my IP. If I put that in the firewall here, then only traffic coming from my IP address is going to be allowed to connect to this server. This can be really nice because then it absolutely stops in its tracks all attempts to brute force your password. And even if a hacker got access to your password or even your SSH key, they couldn't actually log into the server without first cracking your DigitalOcean account or your AWS account or however you're using this. The IP whitelisting can be a very, very powerful tool, especially for sensitive data. As I said before, if you want to take it to the next level, we should use SSH keys, and I'll jump over to my Windows PC to show you how we'd implement that over there. So if we want to connect to our server here via SSH on a Windows machine, we'll first need to generate an SSH key. So it's just a special file that we're going to use in order to connect. So you should have PuttyGen installed on your computer. It gets installed with Putty. And what this is going to do is it's going to generate a public-private key pair for us. You can leave the defaults here, so RSA and 2048 bits, and just click generate. Now, if you just move your mouse around in this area, that's going to generate some random bits of noise, which is going to be used by the algorithm to create our SSH key here. There are a few important bits to think about here. So we can first go down here and we can save the public key and the private key down to disk. So I'm going to do that. I'm just going to save them on my desktop. This one's going to be called public, and the private one's going to be called private. It's asking me here if I want to use a passphrase to protect the key. So in this section, you can type a passphrase here. And what that'll mean is that even if someone did get your SSH key, they'd also need to crack the password on the SSH key to get into your system. Now, for me, that's some next level paranoia. Obviously, it depends on the kind of server that you're accessing. If it is truly that important, then of course do put a password on your SSH key. But for the purposes of this tutorial, I'm going to go without one. So I'll download this and I'll just call it private. So I'll save it on my desktop again, once again in a highly secure location. So that's great. We've got our SSH key. We've actually generated one. How do we actually use that to connect to our server? Your cloud provider might provide some specific way of doing that, but I'm going to show you a method here that works on any cloud provider. All you have to do is you copy this bit at the top here. So it says the public key for pasting into blah, 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 blah. So you copy this, then go back to your Putty window here. So this is a regular terminal into our virtual server, which we should be well familiar with by now. And what I'm going to do is I'm going to go into the hidden.ssh folder. So I'll just go back up a step here to show you. So if you do ls-a, that will show hidden folders and files. You can see there's a hidden file here called SSH. So if you do cd.ssh, if you go inside here, you'll see there's a file called authorized keys. So I'm going to open that up with Vim. Now it's empty. So all I'm going to do is press I to go into insert mode. I'm going to hold Control, Shift, and V to paste, or maybe it's just Control V. Right click seems to have worked for me there. Pasting in a terminal can be annoying. You'll want to check this is roughly the same as the one that you copied there. So all looks good to me. And so I'm going to get out of insert mode with escape and do :WQ, and that's going to get me out of here. So we've saved our SSH key onto the server here. All we need to do is set our PuTTY profile to look for that specific key. So let's open up PuTTY here. Let's load in my server here. So you just go to SSH here, then auth, and it says private key file for authentication. Click browse. I'll find that on my desktop. So you want to click the private key wherever you saved that. And at this point, we can go back here. We can save our profile back down. And now hopefully when I click open on my server here, it should just automatically connect and log in without me having to input a password, because it's going to use this public key. So that worked first time, which it rarely does in my experience, so that's pretty good. I'll hop on over to my Linux machine and show you how you do an analogous thing on Linux or Mac. So we're back here on the Linux machine, and once again, things are a little bit easier with Linux. So in order to create an SSH key, you can just go into, say, any particular folder that you like. So I'm going to go in here and just type the words SSH-keygen. This should also work on Mac. So just give it a name. I'm going to call mine trading. Enter a passphrase. I'm just going to not have a passphrase. That's fine. It will generate our key for us here. So if I do ls, you can see it there. So you've got trading and trading.pub. Now, in order to copy this over to the server, you can do the same thing we did before. You can go inside trading.pub here, and you can copy this over to the server in the authorized keys section. But that is prone to error in my experience, and so there's a fancy tool that you can use called SSH-copy-ID. All you need to do is you need to feed in the private key here, so -i trading, just feed in the private key, and then use your normal logging, so it's going to be root at the IP address. Go back here, root at the IP address. It's going to ask for the password as normal. And there we go. It'll give you a little command here that you can run to test things. But that command should have done everything that we wanted. So that didn't work automatically there. And I think the reason for that is that this trading key needs to be placed inside a special folder on your computer for it to work. So if I go to home here, I'll copy this trading file. I'll go to my .ssh and I'll place it in here. And it should probably work now. If I go back, SSH. No, well, if it's not working for you, the easiest thing you can do is do SSH-I and then just the name of the file here. So -trading. And that'll work just fine. SSH just isn't picking up the private SSH key that we're using here, so you just have to feed it in manually there. There is an SSH config file which you can look into, and that will let you automatically match the SSH keys with specific machines, so you can go ahead and research that if you'd like. One final thing we'll do with SSH keys here is we'll disable access via password. In order to do that, we have to access a particular file. So if you go to vim-etc-ssh-sshd_config, you'll have this file. And if you look down it, you'll eventually see a thing called password authentication. That'll be somewhere down here. So you can see password authentication is yes. All you have to do is change that to no here. And then if we do :WQ to get out of here, and we do system ctl restart SSH, if I can type it properly. Now all attempts to log into our system using a password-based approach will be rejected. So I can show you here with the other terminal, if I just exit out of here. If I don't feed in the private key, it will just tell me that I can't connect unless I have an SSH key here. That's how you know that that's worked. And so now this server is as reasonably secure as you can make it. One further thing you could do is you could use a different user other than root. So I could make a user called Chad and use that user instead of using root all the time. One reason you might want to do that is that with root you have a lot of power, so you can accidentally do things that are very damaging to the system. You can delete files that you didn't mean to, etc., etc. And so with that, we've got a quick look into various aspects of Linux admin that you'll need to perfect in order to deploy your trading systems to the cloud. We can never hope to cover everything that Linux has to offer here in one video, but I hope I've at least whet your appetite and you can now go out and research the topics that I've suggested independently. If you have any questions or suggestions, do post them down in the comments, and I'll see you in the next one.